Section 11.2, Exponents and Scientific Notation. In this video, we're going to use the power rule for exponents, the rule for a power of a product, the rule for a power of a quotient, and the combination of those rules to simplify expressions. In our next video, we will look at writing decimal numbers in scientific notation and then computing operations with decimal numbers and scientific notation. So let's take a moment and just review what we know about exponent rules up to this point. We know that the exponent of 1 is understood when a variable or a number doesn't have an exponent. We know that something to the 0 power is equal to 1. We also know by the product rule that if we're multiplying that with the same base, we want to add our exponents. The quotient rule tells us that if we're dividing with the same base, we subtract our exponents. And then our rule for negative exponents say that if we have a to the negative n, we can write that as 1 over a to the positive n. Now our first new rule is called the power rule for exponents, and it says if you have a to the m, then that raised to the n, that would be a to the m times n. In other words, if you are taking a power raised to another power, you can find the answer by multiplying your exponents and keeping the base. And again, we'll look at why that works. Let's say we had a to the 4th cubed. Well, we know that a to the 4th cubed is a to the 4th times a to the 4th times a to the 4th. But by our power rule, our product rule from previous videos, we know that we would add our exponents when we're multiplying. So 4 plus 4 plus 4 would be 12. And if we look back at our original problem, we would want to multiply our exponents to get our answer of a to the 12th. Let's take a moment and look at some examples using the power rule. If we had x to the 2nd to the 4th, that would be x to the 2 times 4, which would be 8. X to the 5th to the negative 2 would be x to the negative 10th, but remember that we have to replace negative exponents with positive exponents, so that becomes 1 over x to the positive 10. Y to the negative 7 squared would be y to the negative 14, but that would be written as 1 over y to the positive 14. And 2 to the cube to the negative 2 would be 2 to the negative 6, but that's 1 over 2 to the 6th, or 2 being multiplied together 6 times, which is 1 over 64. Now, the rule for the power of a product. If we have A and B, and their product is being raised to the n power, what we can do is raise each one of those to the n power and multiply. So if we have a power of a product, we raise each factor to that power. So 5x squared becomes 5 squared times x squared. Everything's going to get raised to the second. But we know that 5 squared is 25, so our answer will be 25x squared. xy cubed is x cubed y cubed, and we can't simplify that. Since those are different bases, we can't combine them, so that would be our answer. Negative 7ab squared would be negative 7 squared, a squared, b squared. But negative 7 squared would be positive 49, and then a squared, b squared. ab to the negative 5th would be a to the negative 5 times b to the negative 5, but that's 1 over a to the 5th times 1 over b to the 5th, which would be 1 over a to the 5th, b to the 5th. And x squared y to the negative 3 to the 4th would be x to the 8th, y to the negative 12th, but remember our rules for simplification says that we can't leave a negative exponent, so the x to the 8th will go in the top, and the y to the 12th will go in the bottom and become positive. Now the rule for a power of a quotient. Just like when we're multiplying and we raise to a power, if we divide and raise to a power, we just raise both the numerator and the denominator to the power. So when we have a fraction to a power, we raise both the top and the bottom to that power. Y over x to the 5th is y to the 5th over x to the 5th. 2 over a to the 4th is 2 to the 4th over a to the 4th. But we know that 2 to the 4th is just 2 times itself 4 times, and that would be 16 over a to the 4th. 3/4 cubed is 3 cubed over 4 cubed, but 3 cubed is 27 and 4 cubed is 64. So our answer would be 27/64. And the last one, x over 7 squared, would be x squared over 7 squared, which would be x squared over 49. Now let's take what we've done so far and combine some of the rules. So we have negative 2x over y squared all cubed. So that's going to be negative 2 cubed, x cubed, and y squared cubed. But negative 2 cubed is negative 2 times negative 2 times negative 2, but that's negative 8, x cubed. And then y squared cubed would be y to the 6th because we'd multiply our exponents. In our next problem, we would have 3 squared, a squared squared, b squared, over a cubed squared, and b squared squared. So we've used that exponent and raised everything inside the parentheses to that power. Well, 3 squared is 9. A squared squared is a to the 4th, and then b squared. A cubed squared would be a to the 6th, and b squared squared would be b to the 4th. But now we have to simplify because remember, we're not allowed to have the same variable or same base more than once. And notice that we have a in the top and bottom and b in the top and bottom. So that's going to give me 9. A to the, if I subtract when I have division, I get negative 2. And b to the, subtract my exponents, I get negative 2. But that would be 9 over a squared, b squared. Now let's look at two different approaches with fractional expressions and negative exponents. One is to do what we just did. We could make this x to the negative 12, y to the negative 20th, and then switch those as x to the 12th in the bottom, y to the 20th in the top. Or another way you can do that is if you have a fraction to a negative exponent, you can start by flipping the fraction. Do the reciprocal of the fraction and then make the exponent positive. If I do that now, I get y to the 20th, because we're raising a power to a power, over x to the 12th, which is the same thing I got here. So when you have a fraction being raised to a negative exponent, you can either distribute the exponent and then move your negatives, or flip the fraction and change the exponent to a positive. So now let's look at this problem. Since we have 2x squared y cubed over 3xy to the negative 2, all to the negative 2, the first thing I could do is just flip this fraction and then make this to a positive exponent. Well, that becomes 3 squared x squared y to the negative 2 squared over 2 squared x squared squared y cubed squared. Now we'll go through and square everything. That would be 9 x squared y to the negative 4 over 4 x to the 4th, and then y to the 6th. Now we still have some simplifying we can do. These I can simplify. 2 x's on the top would cancel with 2 of the 4 x's on the bottom and still leave you 2 x's on the bottom. Then this y to the negative 4 would come to the bottom and become positive. And now I can combine those and get y to the 10th. And that's your final answer.